Okay, so 4.1 exponential functions. We're going to go through the important parts. Right here it says there's real life applications for exponential functions. We will bypass that for right now. So in general, an exponential function is written of this form. And this B stands for the base, and X is called the exponent. I'm sure you guys have heard this before, but now, so what's the requirements for the base? The base cannot be 0, the base cannot be 1, and it can't be negative. Can't be negative. There's other ways of writing it, but you can't have 0, 0 to any power is 0, that's no fun. 1 to any power is 1, that's no fun. So, and they can't be negative. So down here are these, determine whether the following are exponential functions. So 2 to the x, the base is 2, yes, that's a positive number. 1 to the x, no, can't have a 1. 5 to the x minus 1, yeah, sure. Doesn't just have to be to the x, could be the x minus 1. Okay, here, negative 2 to the x. Nope, negative. Negative, naughty. Negative 2 to the x. Now this one is actually 2 to the x, and then the negative's on the outside of this, so this is okay. This is 2 to the x, and then it's the opposite of it. And this one, no, you can't have a variable for your base. The base cannot equal x. Okay? So if we're graphing exponential functions like 2 to the x, the thing you want to do is make just a little simple table of values. So x and 2 to the x. Okay? Y is equal to f of x. So I'm saying x and y, or f of x. 2 to the x. Put a negative 2 in here. What's 2 raised to the negative 2 power? If you guys remember how exponents work, that's 1 over 2 to the positive 2 power, which is 1/4. So at negative 2, here's negative 1, here's negative 2. The y value is like 1/4, very small. Negative 1, 2 to the minus 1 is 1 over 2, which is 1/2. So at negative 1, it's 1/2. At 0, 2 to the 0, any number to the 0 is 1, so 2, here's x is 0, 2 to the 0 is 1. How about when we put a 1 and a 2 in here? Kind of a sloppy looking thing, but put a 1 in there, you have 2 to the first power. 2 to the first power is 2, so when x is 1, y is 2. And to the second, 2 to the second is 4. So here we are. 1, 2, x is 2, 1, 2, 3, 4. So what happens with an exponential function, you guys have seen them before, they just start growing very rapidly. And on this end, this line didn't draw it very well. It gets very close to the x-axis, but never touches it. So this one says g of x equals 1/2 to the x power. So we'll do the same thing, maybe it'll look a little neater here. X, and then g of x, which is y, which equals 1/2 to the x. So let's do negative 2, negative 1, 0, 1, and 2. See if that looks all right. You can probably see that fairly well. So let's start with 0, 1/2 to the 0 power. Any number to the 0 is 1, so the point 0, 1 is here. Then let's do the 1 power, the first power. 1/2 to the 1 is 1/2. So when x is 1, y is 1/2. 1/2 to the second, that's 1/2 times 1/2, which is 1/4. So if you look, this graph is going like this. Sort of looks like that one, but maybe flipped around. So 1/2 to the minus 1, this equals 1 over 1/2 to the first. And 1 divided by 1/2 is actually 2. So when x is negative 1, y is 2. And when x is negative 2, what you'll see, 1/2 to the minus 2 That's 1 over a half squared, 1 over 1/2 squared, which equals 1 over 1/4, which actually equals 4. So when x is -2, y is equal to 1, 2, 3, 4. So I'm going to turn my paper. So, okay, when you've got 2 to the x, it looks like this. 1/2 to the x looks like this. So what's the relationship between these two? This one reflected over the y-axis is this one. So they're the same, just reflected over the y-axis. They're symmetric.